Hello and welcome back to Jules Bench. Again, my name is Greg Perugini, and today's lab will be on magnetic fields. Now, in your kit, you should have some iron filings as well as a couple of very small magnets. And these magnets, we're going to not only be able to measure a magnetic field, but actually do a calculation of that magnetic field in Teslas. So, as you might expect, we could use the iron fillings to sort of see the magnetic field. Notice there's a white spot around here. What we did was we took a piece of paper and put the magnets under the piece of paper and then sprinkled very lightly the iron filings. Once you do that, you'll see the point where the pull is great enough to capture the iron fillings. So you have a strength at this point enough to clear the area, so to speak. And you can draw that magnetic field. And that's one of the first things you're to do in your experiment. Just sprinkle the powder on. This is a better, closer up picture. And you'll see that pattern emerge. It's strong enough to beat the friction, and that's a key point, that these would normally just sit here on the paper, these iron filings, but they would be dragged into here if the magnetic field was stronger than the frictional force holding them on the paper. The next part of this experiment is a little bit more tricky. You have to do a bit of research to estimate the size of the magnetic field in Gauss or Teslas, depending on what unit you want to use, at a particular location. First, you place the two magnets on a sheet of paper and orient them to each other so that they are attractive to each other. You have to set the poles correctly to do that. Once you do that, move one very slowly towards the other one until that other one jumps to it. Before you do that, of course, you want to make a mark as to where it was before it did the jump. And then when it does the jump, make another mark. And you want that distance, because that distance is what we're going to measure the magnetic field strength for that particular distance. So make sure you measure that distance. And then we're going to use this simplified Maxwell equation to calculate the magnetic field at that particular point. So what are all these values here? We're going to go through it. So the force we know we're going to be overcoming is that this will want to slide in that direction towards the other magnet. You have these two magnets here. And that one will want to slide towards it when it is overcoming the force of friction. Now, if you remember from your first semester, the force of friction can be measured by the coefficient of static friction times the normal force. In this case, since we're doing it on a flat piece of paper, the normal force is positive mg. So, we're going to say that the mass of this particular magnet that is moving is 10 grams. Of course, you need to do that in kilograms, right? And that the static coefficient for the paper and the steel is about 0.35, I should say, 0.35. So you're going to use that to calculate the frictional force that is going to try to hold that magnet in place. And we're going to be overcoming that by the magnetic force. A is the area of one of the magnetic bars. So you want to measure its length and its width. And we're going to use that answer in meters squared. Look up the mu value, which is the permeability of free space. It's a constant. And given that, you should be able to calculate the force. Or, excuse me, calculate the magnetic field using the force, the area, and the mu in Teslas. If you want to divide it by 10,000, you will get the value in Gauss. Depending on your magnets, and depending on how accurate your measurements are, you should be able to get anywhere from 50 to 150 Gauss in your measurements. So, for this lab, first show a picture of the field lines at the barrier level. That barrier level when it just starts to want to come together. You want to calculate and show the calculations of the amount of gauze at a specific distance for the particular magnets. Showing all the calculations, and make sure you show your methodology for how you did this experiment. And good luck.